All right, so on our graphs, we can have graphs that look like this. So, here's our horizontal axis, and so sometimes they're gonna go below, and then they'll come up again and go down. And what happens here? Well, the portion of the graph is gonna be negative, and this portion is negative. This portion is positive. So we're gonna have an accumulation on this piece that goes negative, and then all of a sudden we're gonna go and we're gonna have an accumulation that goes positive, and then we'll come down here. And so there's going to be a negative pieces of some of our accumulation graphs and positive pieces as well. And so, it's going to decrease, 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 and then all of a sudden it's going to start increasing. And so we'll have a kind of a dip, and then we'll start going back up the other direction. And this is an example of this one. So basically they give us, our function here, f of t, and thousands of employees per year. And what they want to do is say, okay, well, first question, what is the area of one box of the grid? Okay, well, so if we look, we go from 3 to 4. So each one of these is a half a unit wide. And it looks like it's going from 0 to 50. So it's a half wide and 50,000 strong because there's thousands here. So half of 50,000 is 25,000 employees. So each box is worth 25,000 employees. So now they say, okay, well, now let's construct a table of accumulation for a of x for 1 to x for f of t. So we're going to, again, this starts at 1. So this isn't a 0. So you have to kind of notice that. That goes 2 to 3 and then 2 to 1. So this is starting at 1 here. So we kind of have to remember that. And we're going to go up by half units. So from, 1 to 1, and that's kind of where it's starting. That's going to give us a 0. So we have our 0 point because we have to kind of have a 0 starting point. And then we're going to go from 1 to 1.5 rather. And so we go, 1, 2, 3, 4, 5. We could probably get 6.5, and then we take that times our 25. So we're going to go to a negative 160 because again, these are negative values down here. So this is a negative region. This is a positive region. And so our accumulated point at that point is negative 160. So, we draw our next point. And then we go from, 1.5 to 2. We add up those, multiply it by that 25,000. And so we're going to get a negative 100,000, basically. Okay. So that gives us, we're down to 260 because we have to add 160 to that. So we get down to here. And then we go to 2.5. We get that little area. And so they said that's a negative 45,000. So we add a little bit more. And then the next one, we look, we have a negative chunk and we have a positive chunk. And it looks like the negative is bigger than the positive. And they say it's a negative by, 5,000. And so we go one final piece. Now we're down at this point right here. And that's when we started kind of switching, going from here to here. Now it's only going to be positive forward. And so all these are going to be positive. So we're going to add. So 3 to 3.5, that's going to add us 33. And so we move up 33. And then we just keep going and going and going. And then our last one, again, it's going to go from 6.5 to 7. And so it's got a positive and a negative. It's more positive than negative. So we're only going to by that 3. And so we go up to that final point of 108. And again, we draw our curve in through our points and we get our accumulation graph. And this is, again, thousands of employees. All right, so that's basically, we've just done A, B, and C. Now D, it says, the number of 20 to 24-year-olds employed full-time at the end of 2001 was 9,473,000. So, if we look at it, 9,473,000. Use this value and the change estimated in part B, which we said was 108,000, to estimate the number of 20 to 24-year-olds employed full-time at the end of 2007. Well, if we started at this, and we're going to add in our value down here of 108. We basically just add those two together. We get 9,580. And again, that's going to be 1,000 employees. So that's going to be our final number after 2007, at the end of 2007. Okay. And again, it's all based on our accumulation graph. We had to know where it went at the end, and we add it to what we had an initial, and then we could get our total. Now, if they didn't give us our initial value, we couldn't do anything. All we could say is, well, it went up 108,000 employees, and that's all we could say. But because they gave us that initial value, then we could actually tell them what that value is then at the end of 2007. All right, the next thing we're looking at is using concavity to refine the sketch of an accumulation function. Okay, so this is going to give us basically a quick way to decide what things are doing on an accumulation function. So if we are up here in this left quadrant, top left quadrant, if our graph is kind of going concave down and it's going in this shape here, then what happens is we're increasing still. But remember, as we increase, it gets slower and slower when it gets closer to this horizontal, and so we have a slower increase. Now, continuing around the circle here, now we still have concave down, but it's going from almost a 0 point, if we look at that horizontal, all the way down, it's going really steep. So this is a faster, and it's a decrease. Now, if we come back down over here, well, we're going, still going pretty fast, and it's still going to be an increase, but we're not really coming down this time. We have to start here, and we're really moving up. And so that's why it's called an increase, because we move from left to right on our graph. And so it's a faster increase. And here, as we think about it, again, left to right, we're going down and we're reaching that plateau down here. So it's a decrease, but it's going slower as we get closer here because it's going closer to 0. Okay, and so that's kind of what all of these words say here, but that's what the graph is going to help us do. So when you look at a graph, we'll know, it's increasing slow or increasing faster, or decreasing slow or decreasing faster. So that's going to help us on some graphs. Now, our book says all that, but then what happens is they kind of make some mess ups here, and they put the wrong values in our table. So I went ahead and typed out the correct values, so we have the correct numbers, or the letters here. All right, so the accumulation function that's based on our rate of change function here is going to be as follows. So this is the accumulation, this is the rate of change. Now, what do we have? Well, we have a relative max at x is equal to a. Well, this is our a, is basically, our vertical axis. Now, can we tell it from our original function? Well, we're going from positive to a negative. And so if we're going positive to negative, that's going to tell us we have a relative max. And if we look down here on our graph, that's what we have here. We have a relative max, okay? Now, keeping going down, if we come over here, now we're going from negative to positive, well, that should be a relative min on our accumulation function. And if we go over here to b, that is a relative min. Now, what happens here? Well, at this point, we'll reach this, lowest point here. So that means it's going to be most rapidly decreasing. And what happens there? Well, that should be an inflection point. And if we come down here, that is an inflection point. It's on the decreasing side, and so that's the most rapidly decreasing. Now, if instead we had something like this, that's going to be a most rapidly increasing, and so what's going to happen is this graph's going to be flipped over the horizontal axis, and it's going to be going up at that point, and so it's going to be a most rapid increase at that inflection point. So that's going to be kind of a key difference. All right, so now let's look at our accumulation function and see what we have. So now we're going to use that picture over here we just looked at and say, okay, well, what's happening here? Well, it's concave down up to our inflection point of C. So, from -5 to our A, it looks like A is not exactly at 0, actually. And so between those 2 points, it's what? Well, it's concave down, and it's going to be slowly increasing, okay? Increasing slower. Now, we're going from here to here. Now we're decreasing. So we have it's decreasing what? Well, it's decreasing faster. Okay, and that's what we would expect until we hit that point of the maximum at that point right here. Then we switch from concave down to concave up. Now at this point, what's happening? Well, we're at this point, so we're slowing down on our decreasing because we're reaching that 0 point. And so that's a decreasing slower. And again, it's concave up, not concave down like it had in the book. And then from here to here, well, that's going to be, it's increasing faster. Okay. And again, based on this part here, we're increasing faster when we're going that direction. So that's kind of how we can use that graph to tell us, increasing faster, decreasing faster, or whatever we're looking at on our accumulation function. All right, so let's stop there and we'll come back for more.